finding is the confirmation of water emission in the day-side spectrum of the ultra-hot Jupiter WASP-121b. WASP-121b is an extrasolar planet orbiting the star WASP-121. WASP-121b is in the constellation Puppy and is about 850 light-years from Earth. WASP-121b is the first exoplanet found to contain water in an extrasolar planetary stratosphere. Stratosphere is an atmospheric layer in which temperature increases as the altitude increases. In the case of a synchronously orbiting high-irradiated planet, if the opacity of the atmosphere is lower at optical wavelength than at infrared wavelength, the vertical temperature profile of the day-side hemisphere is expected to decrease with decreasing pressure close to the infrared photosphere. As such, thermal immersion are valuable diagnostics of the radiative process at play in planetary atmosphere, and in particular the relative strength of absorption at optical versus infrared wavelength. Thermal immersion is a natural phenomenon that involves a change in the normal tendency of the air to close down altitude. Thermal immersion can be inferred by measuring the planetary emission spectrum and detecting opacity band as emission rather than absorption features. The resulting day-side spectrum reveals an water emission band spanning the about 1.3 to 1.6 micrometer wavelength range, providing strong evidence for a day-side thermal immersion. In sum, an water emission feature is exhibiting in the G141 passband, muted in amplitude due to thermal dissociation. This result reinforces the conclusion that the day-side hemisphere of WASP-121b has a thermal immersion. The second finding is the detection of iron 1 in the atmosphere of the ultra-hot Jupiter WASP-121b by dropper resolved spectroscopy. Transmission and emission spectroscopy are key techniques for the characterization of exoplanet atmosphere. Iron 1 is detected in the atmosphere of WASP-121b using both the standard cross-correlation approach and a new likelihood-based approach. Iron 1 is the first unambiguously detected species that would be a major absorber of incoming optical from the hot star that would deposit enough energy in the stratosphere. Iron detection have previously been reported for a range of ultra-hot Jupiter, with iron 1 in particular recently predicted to be an important atmospheric constituent in hot atmosphere. Researchers suggest that iron 1 is the most likely contributor to the temperature immersion detected in the stratosphere.